Hi everyone. So today we are going to do this BW level problem called 3 sum. It is very similar to 2 sum. So here what we have is we are given an array and we are given a target sum. So we should find out all the triplets, all the three numbers which sum up to this number. So so it's the same as this one. So the numbers initially should be ordered in ascending order. So it should be in ascending order like this one. And then the triplet themselves should be ordered in okay. So if no three numbers, the function should return an empty array. So if no numbers give this target sum, so it should just return an empty array. So this problem is very similar to that of two sums. So let's see how we are going to solve this. So so now if you so now the first step what we have to do is we need to sort. So I have already taken this input and I have sorted it. So after sorting, we need to keep three pointers kind of. So we'll have one at current. So this is the current number, and then to the right of it we'll keep one left pointer, and here we'll keep a right pointer. So what we are going to do is we will check these now after this point two pointer concept over here. So first we'll check for -8, -6, and 12. So -8, -6, and 12 will come to 8, 10, 11, 12, 13, 14. So it will come to so it will come to -12. So -14, it will come to -2. So -2 and the target sum over here, what we want is target sum. So let us call it TS. TS is equal to 0. So TS is 0, so now we have -2. So -2 is very much less than 0. So what we do, we move this one over here. So next we continue as usual. So now we do -8, um, -8 plus 1 plus 12 is equal to 13, 12, 11, 10, 9, 8, 7, 6, 5. So okay, 5 is greater than 0. So we have to reduce it. So we get this one to here. We move right pointer to the left. So now we have -8, 1, and 6. So now we have -8, 1, and 6. So 6 plus 1 is 7. So 7 it is comes to -1. So -1 is very much lesser than 0. So we move left pointer. So now we have -8, 2, and 6. So we will just write it. When you say 2 and 6, so 6, 7, 8. So here it is 0. So we need to add these three numbers. It will already be sorted, so we don't need to worry. So we are going to add these 3 -8, 2, and 6 into one array, and we will add it to the list. So next we'll continue. So here we have here we will have -8, 6. So here we will have -8, 3, and 6. So it will come to -1. -3, 6. Okay. So 9 minus 8. So it will come to 1. So it needs to be reduced. So we need to move this one. So now we have -8, 3, and 5. So minus 8, 3 and 5. So again we found one more. So we are going to add this one to the our result array, to our result list which contains an array. So we are going to add this one, and next when they both are greater than or when they are equal to, we we come out of this inner for loop, and then we we move this one over here like this. So once we do that, we will again come back here, and again we'll come back here. So sorry, this left pointer and right pointer, we will just keep it like this way. Yes. So next after that we'll continue with the same what I did. So each time we'll check, and whenever we get the target sum which is 0, we add it to the list. So we keep on going till the end, till we get something like this. So till here we keep going. So next, so the end condition will be array index. So this array index, what we call this current array current index, must be less than or equal to 3. So LP and RP. So I'll tell you what we are doing in the code walkthrough. So let's get into this one. So first step, as I said, we need to sort the array. So we do arrays dot sort, and into that one we keep array. So and then we need to store the result list. So I'll just copy this. It should return me a list of integers. So I'll put this one here. The result list is equal to new list of integers. Okay. So now that we have sorted, so now we start the array. So like I said, this array goes from, let's call it, so this is the current number whatever we are pointing. So let's call it current index. See what I was talking about. The current index is equal to 0. Current index must be less than or equal to arrays dot length minus 3. So length minus 1 will give this one, length minus 2 will give this one, length minus 3 will give this one. So why we are doing this? So current index should stop over here only, because we need to give, because LP is current index plus 1, no? So we'll stop this one over here only at the third one, L minus 3, so that this won't give an array index out of bound for LP. So current index plus plus. Okay. So next thing what we will do is, while this LP while LP is less than RP. So we go here. So before that, let's declare. So let's declare LP and RP. So LP, like I said, LP will always be current index plus 1. So int LP is equal to current index plus 1, and rp is equal to arrays dot length minus 1. So rp will always be pointing to the last one, rp. So next, while lp is less than rp, what we do here is we will check the sum. Int sum is equal to array of, so we'll check for all this and this. So array is the current index plus array of lp plus array of rp. So if we do all that, we'll get the sum. So sum if sum is equal to target sum, what we do is, like I said, if it is equal to a target sum, we add these three numbers to the list. So we'll create one array first. So int, what do I call this? Int let's call it arr is equal to, so new int, let's create the array. So array current this is one of the elements, and then array of lp, array of rp. So and then we add this to result 615, an integer array, not a primitive one. So I'll just call this one integer, int so result this dot add arr, just call this solution. So next, okay, so if we get the sum, we just add it. Else, after adding, we do some lp plus plus. So once if we get the sum, something we have to move now. So just do lp plus plus. Next, else. So if you don't add the sum, if you don't add this line, okay, and if you get the sum, then none of the statements will get skipped, and then again it will come here. Okay, sum is target. None of these elements will move left or right, and then again, like, it will keep going in an infinite loop. So we add this one. Else if else if sum is, is greater than target sum. If the sum is greater than target sum, we need to do rp minus minus, rp minus minus, then else. So equal to over, greater than or is also over. So lesser than is the only available one. So else we do lp plus plus. So we move the left pointer if sum is lesser than the target sum. And then, so this is the end of the while loop, end of while since what is this end of for and this is the end of the method. So this is 154. So just call it array list. Array list. So string return statement. Oh, if not. So in the end, we need to whatever this result set we have now, we need to return that one. Return result list. Okay. So that's it, guys. So over here, what's the time and space complexity for this one? So this time complexity will be n log n because first we are sorting and then plus so after sorting we need to so we are iterating through each so worst case so we go if we have C over here okay LP and RP worst case we might have to iterate we have to iterate through all the solution and then in the end we need to move C till the end over here also so it is n square complexity so but n log n is so n square is very much greater than n log n so we can just ignore this so time complexity will be n square and the space complexity will be so worst case so we might have everything in the array as the solution list something like this one so space complexity will be O of n so let's see if I'm right yeah so n square and then space complexity yeah so that's it guys this is how you solve this one uh, thank you for watching